In this video, we are discussing one of the most important topic, that is red black tree. So it is similar to your binary search tree, because the elements are added like binary search tree, how you were adding the same way that we are adding here. But you can tell this as a balanced height balanced binary search tree. This is a height balanced binary search tree. So it follows some set of rules. The first rule is it should be the node should be black. It should be either black or red. That means what the node that you are inserting, right? It should be black or it should be red. It should be red. So, and second thing is root should always be black. Root node should always be black. And the third point is null nodes, right? Null nodes should always be. It should always be black. So nodes should always be black. And new node that you are inserting, right? The present new node, if you are inserting, it should always be red. It should always be red. Okay. The number of black nodes from leaf to root node must be same. That means number of black nodes from leaf node. You are going to count the number of black nodes from leaf node to the top, that is root node. Then that should be what? From every direction it should be same. So height should be this thing, because I said it is a balanced binary search tree, height balanced binary search tree. Height should be this much, log n to 2 log n, and n is nothing but the number of nodes. If you substitute, you will get the height between this range itself. Now there should, and the seventh point is there should be no two consecutive red nodes. There should not be two consecutive red nodes. Two consecutive nodes shouldn't be adjacent. So this is my rules. So now this is my the rule that I am going to explain. So now let me know how this is an example of red black tree. So all nodes should be either red or black. So all are red or it is black. Okay, it is proved. Now root node must be always black. Here what is the root node? 30 is the root node. So it is black. It is satisfied. Null node should always be black. Here imagine I have 10. So after that I don't have anything. It is a leaf node. Imagine like it is a leaf node. So if it is a leaf node, it will have a left and right child as what? Null. Obviously it should have a null nodes. That is why it is called as leaf node. So all the null node what you are seeing that I scratched, right? That those are black. So it is black. So it is also satisfied. Now new node should always be red. So this I am going to explain you in this video only. But in this example I can't explain. So now the number of black nodes from leaf node should be same. So let me count. Here I have black node. You can count this root null node. It is so much like you don't need to count null node, right? So every node is ending with null node, even if you count or if you don't. So it will be there will be no difference. But still, let me count. Here I have one black node. Here I have two black node. Here I have three black node. In this direction, when I went from this leaf node, it is from this end to this root node. You have got three nodes, right? So okay, remember it is a 3. So again here also 1. This is again you will go here, you will go reach here 2, then 3, again 3. Now again start from here 1, 2, 3. So you are reaching 3. Now from here 1, 2, and you will go here then 3. So you are reaching 3 height. The number of black nodes are 3. So again 1, 2, 3. It is also 3. Again 1, 2, 3. It is also 3. Now 1, 2, 3. It is also 3. Then 1, 2, 3. So you satisfy this condition. Now what? Now you have satisfied all the conditions, and height you can check it. So there should be no consecutive red nodes. Again, the consecutive means here you have red node, right? Imagine I had like this, like I had a node coming from here to here, then I will add a red node, red here. Imagine it is 5. So is it a red node tree? No, it is not, because consecutively I have red. It should not have. So let me make it as okay. Now there are two certain cases that you need to follow. These two rules are so much important, and for these two rules you need to know AVL trees that I have discussed in this tree playlist. So go and check out if you have not seen. If you have seen, it is fine. Now what? The first thing I am going to take is the first case is this. Imagine you have a root node which should be black. Obviously it should be black. Now imagine you have a red node here, you have a red node here. So it is a red node tree. Obviously it is a red node tree. It is satisfying all the cases, all the rules. So now I'm going to add a new node. Imagine it is like 10, this is 20, and this is what, 5. It is binary search tree. It is just similar to binary search tree. I need to add 25. Okay, add. So when you are adding new node, you should be red. So it should be red. I think let me add 30. So it is a red black tree. No, it is not a red black tree. So reds are coming consecutively, which is not a good thing for us. So what you need to do? The first thing that you need to do is look at the uncle. See, this is the uncle. 5 is the uncle, because see, for new node, this node is what? Yes, that is 5 node is what? Uncle. Because see, uncle means what? The parent siblings are uncle. So for this node, its parent is 20 and its sibling is what? Yes, 5. That is 5. Here it is, that is 5. I am writing like it is a yes. So let me make it as a 5. Right? Uncle, this is uncle. Look at the uncle. Here uncle is what? Red. Uncle is what? Uncle is red. So you should follow some set of rules. So if uncle is red, you recolorize. You do recolorization of all the nodes except the new node that you added, because new node should always be red. So what you do is you convert this uncle to black. You convert this parent to black. So again, why I am doing that? And you convert this to red. So why I am doing that? Fundamentally, let me talk how fundamentally it works. So it is a black. So imagine this is a again, this is a red tree. So first thing that comes to your mind is to correct this red black tree. So in order to correct this red black tree, what you may do is you will convert this into black. So parent node you are converting into black. So that is what the common sense that you are going to put. So it is fine. Now it is fine. No consecutive red nodes. It is fine. But let us count number of black nodes from year to year. So it is 1. Forget about root node. I am not counting that. That is null nodes. I am not counting. Just root node is 1. Again, from year in this direction we will get 2. So there is a break of another rule. So for that reason, I am going to convert uncle to what? Black. I am making uncle to black. So let's not break this rule. That is why I am making uncle as black. And since I said I need to recolorize, I will recolorize this root node also. Actually, this is normally it is a part of the bigger problem, right? So I will make it as a red. Usually there will be no problem, but here there is a problem. What is it? Root node is what? Red. Right? I recolorize, but it should be black. So what you do? You just recolorize it to black. That's it. You are going to make it as a red. No problem. Unless it is a root. If it is a root, you need to keep it as a black itself. That is what fundamental thing here is. So if I draw this thing again, let me draw this again. So what you are going to get is, here you will get black, then here you will get black, then you will get here black, then here you will get red, and it satisfies all the condition here. Everything is fine here. So let us go to the second case, which is the most important case. So here in this case, what I am going to discuss is same thing. Imagine I have a root node, and imagine I have an uncle who is null. So imagine I have again a red node, like a red node. Again I need to add a new node. Imagine it is A, it is U uncle, this is B. So imagine I need to add, forget about the color what I am labeling. So the circle you keep in mind, that is what the black red. And so if you are getting confused, let me label it as in white. So this is uncle, this is root node, and this is what? This is parent. What is this? This is what? Let me call it as this as A. I said right. Let me call it as A. What should I call? Let me call it as B. Now you need to add C. You need to add C. So imagine that C is greater than B. So obviously there is no chance for you. It is just like a binary search tree. You need to add a C. Imagine you are adding C. So you are adding C. Now there will be a break of condition. What you are going to do? You are going to see the uncle. What is uncle? Uncle is black. Uncle is black. So you need to do rotations. That is LL rotation or RR rotation. Any rotation. LR rotation, LR, RR rotation. For here, let me give some new name here. If you do LL rotation or you are doing RR rotation, let me give that name as zigzag rotation. Zigzag, ZIG. So what if you are doing LR and RL? So at that time you can call it as a zig, SIG zig, zag, ZAG, zag. So this is what we are going to call. So now here, if you observe, here it is like a right skew tree, So it is a right skew tree. What you will do is you will make it as you will rotate to left side, right? Left side you are rotating. That means LL rotation you will do. That means zigzag rotation you are going to do. So let me perform zigzag rotation, and directly I am going to perform, because by thinking that you have completed AVL tree already. So if I do, B will come at the middle as a root node, and root node should always be black. So B will come here, and A and C should come here. A is this and C is this. Uncle will be where? Uncle will be here. Uncle will be where? Uncle will be here. There is the uncle. So number of black nodes from this end is 1, 2. From this end, it is normally it is null, right? If there is nothing, it should be null. So 1, 2. So you are satisfied. So you are going to do this. Or else imagine, let me take a zigzag rotation for your satisfaction. That means you will know it is actually working. So A, now it is what? Uncle. Again, same thing I am taking. Again, let me take it as a B. So now I need to add a new node. Imagine that C is less than B and greater than A. Greater than A. So where you will add? Normally common sense is you need to add here, but it should be what? Red. So here it is like what? It is it gives you idea that if you have completed AVL tree, you need to do first. You need to do right shift, right pull, then you need to do left pull. So right pull first, then left pull. RL rotation you need to do. And again, this is zigzag rotation. So if I do, I will get the B will actually come here, C will go there, and you know how it works, right? So C will come at the middle. So C will get here, then A and B will come here, and which are red. So this is how introduction to red black tree. So if you have any doubt on any tree, even data structure, concept of data structure, you can look out my channel. So thank you.